Because this is freaking impossible.
Okay, so what we'll do is we want to, first of all, this is all grouped together. It's like we have this one long line, right? When you see the number first, it always, like, what do we always do when we see the number first in this type of situation? We want to swap it and take out a -1. So I'm going to rewrite this as negative x minus 3. And then you've got 10x, 5, and x squared minus 9. Can I factor the x squared minus 9?
Yes.
To be what?
Square is x plus 3x minus 2.
And then I've got the 5. So then I'm going to take out things that can cancel. What are things that can reduce? The x minus 3's. And then the 10 and the 5 reduce, and I have a 2 on top. So I have negative 2x over x plus 3. On the second one, I'm going to look at each part. The first step of any factoring problem is pulling out the greatest common factor. So top left, I can pull out a what? Top left.
8.
And I'm left with v minus. On the bottom, I can pull out an 8, and I'm left with v plus 6. Top right, I can factor that to be v plus 3, v plus 6. And then bottom right, I can pull out an 8, v, and I'm left with v plus 3. Now I cancel. V plus 3's cancel. V plus 6's cancel. 8's cancel. So I'm left with v plus 7, or v minus 7 on top, and 8v on bottom. When I'm dividing, what do I do with the second fraction? When I'm dividing, you flip it. So it would be times n minus 4 over 1. Then you got it wrong. So it would be 8 n minus 4 over, I can pull out a 4n, and then I'm left with n minus 4.
Wait, why did you have to flip it?
Because it's dividing. So when you divide, you flip and multiply. Then the n minus 4's cancel, and the 8 over 4 cancels, and I'm left with 2. 2 over n. So this number 4, I would flip it to be 4b plus 10 on top and 2 on the bottom. How would I factor the top left? B plus 3, b minus 5, over, I can pull out a 4, and I'm left with 2b plus 5. On the top right, I can pull out a 2, and I'm left with 2b plus 5 over 2. Now, things that cancel, 2's, 2b plus 5, and then I'm left with b plus 3, b minus 5 over 4. So we just kind of skimmed through that since we learned it in chapter 4. That's just going to be something that is expected that you know. Multiplying, dividing. But today's lesson is going to be about adding and subtracting.
Is that easier?
Wait, hold on. Can you go back to this?
Uh-huh. You must have a, what was that, Tommy? Common denominator. Good. So number 1 is easy because they already have a common denominator, right? So it would just be 6 over 9, which reduces to 2/3. What about number 2? 3x over 9.
So is that just like
X over 3. What about number 3?
Like where this is
10 over
going.
x, y to the third.
Perfect. About number 4.
9y minus 3 over y squared minus 5.
Good. Can anything cancel?
Yes.
The Y.
Hmm.
Would you?
No, it can't
Mm.
because there's the minuses in between.
Did you just say the Y's can cancel?
No.
I didn't think so. Because if you did, you would have killed a puppy. Puppy needs to stay alive. We don't cancel it. I could, however, do something to the top.
You can factor out a 3.
Yeah, I could.
Would we need to? If it,
No.
If it doesn't do anything for canceling
If it doesn't do anything, then you can just leave it.
Yay.
Okay, what about number 5?
Oh, give me a second here.
6y minus 4.
So we've got 1, positive 1 minus a
Y
negative
plus
5.
6
Yeah.
Over 2y is 3y plus 6 over y. Or we don't cancel.
So I can take out a what at on the top?
6.
And I'm left with y plus 1 over 2y. And then what can cancel?
3.
The 6
I think you
and
can turn it
2y.
into 3.
The 6 and the 2. So I'm left with 3y plus 1 over y.
I don't have an eraser.
Can the y's cancel here?
No.
Thank you. That's what I like to hear.
What are you, crazy?
All right, now let's work on finding a. So all of these had a common denominator. Let's talk about how to find a common denominator. So the first thing that you will do is you will change everything to factored form. So we're going to factor everything first.
Thank you, McDonald's. Love you, McDonald's.
Then you're going to multiply both the top and the bottom, or numerator and denominator, by any missing factors. Then you add or subtract the numerator. So, I'm going to highlight my denominators. I want them both to be the same. And you have to basically bring the smaller numbers up, or the smaller degrees up. Like, you have to go bigger. Can't go smaller. Okay? So I'm going to look at the two numbers. I've got a 5 and a 10. What's the common denominator between those?
5x1.
I can't bring it back down.
Or 10.
Can't bring the 10 to a 5, but I can bring the 5 to a 10. Right? So I need to multiply the left fraction by what?
2.
2. So I'm going to put a 2 on top, 2 on bottom. Now, I'm going to look at the x's. I've got an x and an x squared. What's the common denominator between those two? X squared. I'm going to have to bring everything up. So they can both be x squared if I multiply the right fraction by what? X. And then the y's, I've got a y and a y squared. What do I need to do?
Put a y on the left.
Put a y on the left. So
Multiply the left.
the left is multiplied by 2y, the right is multiplied by x. So I'm going to rewrite the numerator as 12y plus 5x over 10x squared y squared. And I just put it all in one. Because once you've created this common denominator, they can join together.
Oh, see.
Can I do anything from here?
Yes.
Nope. Nope. I'm done. I can't simplify the top any. So I am done.
I don't like how simple it sounds.
Okay. From here, it's already in factored form. There's nothing else that I can do. So I'm going to look at my denominators. I've got 6x and then 5x minus 4. Now I'm just going to look at the numbers. I've got 5 and I've got 6. 30. So that means I need to multiply the left by what? 5. And I need to multiply the right by 6. Now the x and the x minus 4 are treated as two separate things. Like one can never become the other. So basically what I want is for them both, like I want the left side to be multiplied by x minus 4. I want the right side to be multiplied by x. So that the common denominator becomes 30x, x minus 4. Like one can never become the other. They're separate factors. So basically I'm just swapping them.
So you're multiplying 5x minus 4 and then 6x, basically.
Perfect. So 5x minus 4 and 6x. So I end up getting 5x minus 4 squared minus 18x.
Can you cancel out the x minus 4s?
Not yet, because you have that minus sign in between, like right here. So I can't cancel the x minus 4s because that would be killing a puppy. If everything were multiplied by each other, if it were like 5 times x minus 4 squared times 18x, then that would be okay.
Okay.
But you have that minus sign, so no. And from here, I'm trying to decide if I want you guys to multiply it out or not.
No.
Please no.
If it doesn't help us simplify, I don't think we should have to multiply it out.
Agreed. I second that.
Yeah, let's just leave it like this.
We get this homework. Or, no, this homework.
Wait, are these like 5-page notes again?
Okay, now let's go to the next one. This is where we're going to get some practice factoring. Okay, number 8. Let's factor the two denominators. What would the left denominator be?
X plus 3.
X minus 3.
Good. And what would the right denominator factor to be?
3x minus 3.
Good. So now I'm looking at both of them.
So you would
The common denominator would be what?
3x, x minus
3x, x minus 3. So I would need to multiply the left fraction by what? 3. And then the right fraction by?
X.
Good. So then the numerator becomes 12 minus 6x. Now this is an example where you would need to simplify.
Wait.
Because what could I take out on the top?
3.
6. So I'd be left with 2 minus x over 3x, x minus 3. And then what cancels?
The 6 and 3x.
And I'm left with what on top?
2, 6 minus 2x.
So it would be 2 minus x over x, x minus 3. And then I could be done from there.
It'd be so much more fun just to like finish multiplying that out.
They could.
I know, but like it feels like you're missing a step every time. Like there's no like.
Tommy, you do you. Whatever you want to do.
Yeah, but then you're gonna count me off for it.
No, I'm not. If you wrote that as 4 minus 2x, I would not count you off. All right, number 9. Here are my denominators. Let's factor them. X plus 5, x minus 5. And what about the right-hand one?
X plus
x plus 5,
Less.
x plus 1. What's the common denominator?
X plus
X
5,
minus-
X plus 1, X minus 5.
Good. X plus 5, x minus 5, x plus 1. We don't count the x plus 5s twice. We only count for them once because they both have that in common. So what does the left fraction need to get multiplied by? What does it not have?
X plus 1.
The x plus 1. And what does the right fraction not have?
X
X
minus
minus 5.
Good. So then the top gives me 4x plus 1. So let's just say 4x plus 4. I'm going to go ahead and multiply this out. Plus 6x minus 30.
Wow, later than I was.
There's no
Thank you.
excuses.
So then what is the top combined to be?
This is the hardest.
10x minus 26, and then I can pull out. Can I pull out anything
Well,
Well, like a 2.
like a 2? I think that's it.
Dinner.
So 2, 5x minus 13 over x plus 5, x minus 5, x plus 1.
I already know I'm just gonna forget to factor.
Yep.
Do you still have the answer for number 7 on it?
It was 5x minus 4 squared minus 18x. Yes.
How do you know, like on number 8 and 9, how do you know that the bottom is what it should be? Like the common denominator?
So
Yeah.
when you factor everything,
Oh, my toe just.
it needs to have all of the factors. But if 2 of them are repeated, you only count them once. So basically you want to put what they all have in common, and each factor needs to be included on the bottom. So I have
And then
each unique factor needs to be included on the bottom. So x plus 5, x minus 5, x plus 1. And these 2 are repeated, but I only need to count them once since they both have it.
and so like on number 8, you combine the 3 and the x together,
Mhm.
and you do
But they both have x minus 3 in common, so I only count that once. But it needs to have an x and it needs to have a 3. Does that make sense?
a little bit.
Okay, and it just takes more practice. So let's do 2 more.
There's like 1, 2, 3, 4, 5. There's like 6 more.
There's a couple more, yeah.
Why would you just say 2 more then?
Okay, so let's try.
Do we number 11?
We are going to do number 11, but right now we're going to do number 10. So these are already factored, and they're different. So the common denominator needs to include both of them. So what would it be?
Number
C
10
plus
or
2,
C
C
plus
minus.
Number 10.
Okay.
C plus 2, C minus 2. So the left fraction needs to get multiplied by C minus 2. The right fraction needs to get multiplied by C plus 2. So the top becomes 2C squared minus 4C minus 3C squared minus 6C.
I thought you were talking about just the left side, and I was like,
'Cause it's
where
minus
are
right
you
here.
getting this?
Oh, you kept going.
Yeah, I know.
I was like, how
Oh,
do
no,
you
I
get
just-
numbers from one
No,
side?
I just, I foiled. Then I combine my like terms and I get negative C squared minus 10C.
Can you simplify that?
I could. What could I do? I could take out a what?
Negative.
Wait,
A negative C.
I thought, wouldn't it be, because it's a negative, and then it's minus, wait, do you not count the negative in the middle because it's not?
Well,
not
it's
our-
like putting
it's
it
not
right
our
here.
Equations?
Yeah.
Okay.
Over C plus 2, C minus 2.
Miss McKinley,
Uh-huh.
again, we don't have to factor it out if it doesn't cancel anything, right?
No, but in this case, we don't know if it factors anything out. So I'm gonna keep going until I figure that
Okay,
out.
the rest of them, I think we know how to do, but they just look like really long and tedious. They don't look hard. honestly.
You know it's getting more difficult when you see more letters and less numbers.
Okay, what about number 11? Let's just start with what our common denominator is.
It's going to be 2x
Might as well be
minus
2.
2x minus 1 to what power?
cubed.
So the first fraction needs to get multiplied how many times?
Once.
Just once. The second fraction is good. The third fraction needs to get multiplied by it twice.
Couldn't you multiply or like divide the second two and then like
No, because you can never go smaller. Always gotta go bigger.
I don't
So first one would be 4x minus 2
Oh gosh. Here we go.
plus 3 minus 4 2x minus 1 squared.
Wait.
And let's just simplify the first part of it. Let's not FOIL it all out.
Can we cancel out
So let
2x
me-
minus 1?
So just plus
wait, why is it 2x minus 1 to the third? Why don't you use
Squared.
the-
That's the biggest one.
You just choose the biggest one for that? Is that
Mhm.
a problem?
So we're not simplifying it?
No.
Okay.
So it would be 4x plus 1 minus 4 2x minus 1 squared over 2x minus 1 cubed.
Can the 2x minus 1s cross out?
No.
I can't.
You know what? I'm gonna have us keep simplifying it because here's what's gonna happen. You're gonna think that the 2x minus 1s cancel out because I've been asked that question twice. So let's FOIL it out and keep simplifying. I want to FOIL this. What would that be?
4x squared. Minus 4x plus 1.
Yep. Then I want to distribute 4x plus 1 minus 16x squared minus 16x minus 4.
Wouldn't it be plus?
Yep. Thank you. Now combine my like terms. And I would be left with negative 16x squared plus 20x minus 3 over 2x minus 1 cubed.
One of these times she's just
Yep.
gonna go, okay,
Will we
now I'm
ever
done
have
with
to
the easy
factor out
ones.
the denominator to?
No.
That's what always happens.
No.
We get like
Okay.
super easy ones and like.
And then it just
and then
flips.
like,
She makes
flip.
it seem
really hard ones.
All right, let's look at number 12. Now there's two things I could do here.
Ignore it.
I could take the second fraction, flip, and multiply.
Yeah.
So let's do it that way.
Let's not even do the second way. Just
Okay, let's just do the first way right now.
one way.
So that means it's going to be 5x plus 10 over x plus 5. Now, since you guys are experts at multiplying across, I'm going to let you try this one. The next one, we've got pluses in the fraction. So I've got like this plus sign and this plus sign. So this is called a complex fraction.
Yes.
I think it has an appropriate name, wouldn't you
They
think?
weren't already
Yeah.
complex.
But these are actually some of the easiest to answer, in my personal opinion, and I think it's kind of fun. So what we're going to do
No, why do you
is we're going to
propose?
circle every single little denominator. So there are 4 of them. So we've got 3, 2x, x, and 2. Now I want to find a common denominator for all 4 of them.
6x.
6x, good. And I'm going to multiply both the top fraction and the bottom fraction by 6x over 1. Okay, so it's like 6x over 1 on the top, 6x over 1 on the bottom.
What if I ran a room?
What do you mean?
Like, there's just no room for me, right?
Okay, well you figure it out, Graham. I'm gonna let you be a big boy and figure it out.
You can solve this problem. I think you can solve it.
Once you do that, this is now gonna get multiplied to all 4 baby fractions. Okay? So what happens when I multiply 6x by 1/3? What does that become? So imagine taking 6x times 1/3. Because what I'm gonna write the long way. 6x, it's like 6x over 3. What does that become?
2x.
2x. Then I've got 6x. So imagine taking the 6x, it's canceling all of the little denominators is what it's doing. So 6x over 2x reduces to what?
Wait.
Like if I take 6x over 2x, it reduces to just 3. And 5 times 3 is... So what we're doing is we're taking our common denominator and we're canceling out all of the little fractions, so it just becomes 1 fraction. Now I'm going to do the same thing on the bottom.
Wait. How is the second one 15 only?
Because the 6x over 2x reduces to 3.
And then 30 divided.
And then 3 times 5. So when I'm doing this, I'm really looking at my common denominator and my denominator. And I'm canceling that first. And then I'm multiplying it by whatever's left over. So 6x times 3 over x. The 6x and the x reduce to just be what? 6. And 6 times 3 is? And then plus, I can't even see the last one. Is that 1/2?
Yeah.
Okay, so 6x divided by 2, 3x.
That was fun.
From there, thank you. From there, I see if I can pull out any common factors. I can't do anything on the top, on the bottom. I can. So 2x plus 15 over 3, 6 plus x, and then I'm done.
Can I? If it,
I'm just going to try and factor it if I can. So I want the simplified version.
does it matter if I do 3x plus 18 or
That's fine. Okay, let's look. These are the last 2, right? Perfect. So I'm going to highlight or circle my little denominators.
XY.
X, Y. Good. So that means the denominator is going to cancel for every single one.
Does it have to be xy over 1 or is xy?
It's the same thing. You can put over 1 if that helps you to know that it's 2 separate fractions. I just kind of do x, y because I know. So what's left over when I multiply xy by 3 over x? What's left over? Good. 3y plus 5x over 5y minus 1x minus x. Perfect.
Did you even do the math, or did you just, like, you just knew it was going to flip to the next, like...
What do you mean?
Never mind. I get it.
Is that making sense? I will normally just do it in my head there. I'm not writing a lot out because I'm just thinking, how does that numerator and denominator cancel? And then what's left over? Okay, what about...
So you can't simplify that anymore because of the plus and minus?
Right, you can't simplify that anymore. And there's no common factors or anything.
Oh.
Okay, what about here? Now I've got 3x. So I'm going to multiply the top by 3x and the bottom by 3x. And I'm going to distribute. So what happens in the top left? What's left? Nothing, because these are like technically over 1. So 3x times x is what?
3x squared.
Good. Minus
9.
9 over 6x squared. Good. Minus
Or
X squared.
x squared. Good. Okay, I want you to try simplifying that.